If p is greater than 0 and q is greater than 0, prove that p plus q divided by 2 is greater or equal to the square root of pq. So the first thing we're going to do is bring the square root over the inequality sign, and it's going to become squared. So we're going to have p plus q over 2 with brackets around it, and all this is going to be squared is greater or equal to pq. So p plus q over 2 squared is going to be p plus q over 2 multiplied by p plus q over 2. And this is still greater or equal to pq. So when we're multiplying fractions, we multiply top by top and bottom by bottom. So p plus q multiplied by p plus q, I'm going to work it out over here as rough work. So p by p is p squared, p by q is pq, q by p is pq, and q by q is q squared. pq and another pq give us 2pq. So we end up with p squared plus 2pq plus q squared. And this I'm going to write down here as the numerator. And then 2 by 2 is 4. And this is all greater or equal to pq. So then I'm going to multiply across by 4 to get rid of the fraction. So these 4's will cancel. And I bring down the p squared, the 2pq, and the q squared. And this is greater or equal to 4pq. Now I'm going to bring the 4pq over the inequality sign, and it becomes minus 4pq, and that is greater or equal to 0. So 2pq and minus 4pq is going to give us minus 2pq, and we still have the p squared and the q squared. Now I'm going to break apart the minus 2pq to give me minus pq and minus pq. So now I have 4 terms, and now I'm going to do factorization by grouping. So I'm going to take the first 2 terms, p squared minus pq, and I'm going to factorize it, and I get p multiplied by p minus q. And then I'm going to take the second 2 terms, which is minus pq plus q squared. I'm going to factorize them, and I'm going to take out the minus q as the highest common factor. So I'm going to have minus q multiplied by p minus q, and that's all greater or equal to 0. Now I notice I have p minus q inside both brackets, so p minus q is one of my factors. I then bring down the p in front and bring down the minus q that's in front, and I have p minus q as my other factor, and that's all greater or equal to 0. Since I have p minus q multiplied by p minus q and they're the same thing, I can simplify to get p minus q squared is greater or equal to 0, and this statement is true because anything squared is going to be greater or equal to 0. Therefore this proves that this statement is true.